This video is about the demo of lab 8. It's about to reproduce a circuit for amplitude shift keying using discrete components. The objectives of these labs are to generate ASK signal both on hardware and software tools, use diode detector for demodulation of ASK signals, evaluate the effects of ISI on the performance of baseband transmission system. Students must go through the experiment entirely to become familiar with the objective and performance and its hardware performance. Before performing the hardware, let's go through the schematic diagram of the experiment. We will use three blocks to generate ASK signal. First is the sequence generator, second is the adder, and third is the multiplier. So we will use a clock of 2 kHz, which is the message signal from master signal, a variable DC input to a second input to a adder, and first input taken from a sequence generator. The output of adder will be input to a multiplier, and the second input of multiplier will be the 100 kHz analog signal from a master signal. The output of multiplier will generate ASK. Now we will implement this circuit on a hardware. As we seen in schematic diagram, we will use a sequence generator. Our adder, multiplier, a message signal of 2 kHz, put that signal into an adder, and the second signal is the variable DC from variable DC module. The output of adder to the input of amplifier, multiplier, sorry for and Y input of 100 kHz from master signal. Now the experiment has been set up. The output of multiplier we will see on channel 1 port A1. The construction of circuit, we can see our output on oscilloscope. Yellow one is the generated ASK wave signal, and blue one is the input signal, the message signal, which we further converted into ASK. For the performance of discrete experiment, for the modulation of ASK and demodulation of ASK using discrete components, we use these circuits for the modulation and demodulation. For modulation, we set up our experiment using this circuit, in which we take a message of 100 Hz, carrier of 1 kHz, resistor, base resistor of NPN transistor 39 kilo ohm, and its emitter resistor 1.8 kilo ohm. The output, we can take its output on the emitter terminal of a transistor. For demodulation of ASK, we use this circuit, in which we use op-amp of model 4741 and resistance, one resistor of variable resistor of 10 kilo ohm, 100 kilo ohm, and capacitor of 0.01 microfarad and diode. And signal will be input from this side. Now we will construct these circuits on breadboard to perform the experiment and generate ASK more and generate its modulation and demodulation using discrete components. We set up the experiment as we discussed before according to the circuit diagram which is given, and this input signals message signal is generated from a sequence generator of almost 100 kilohertz or 100 hertz, sorry, and the other carrier signal of 1 kilohertz from signal generator of generator 2, and its output has been taken on meter side and it is shown on the oscilloscope. The output which we are getting is looked like this, which is actually the ASK signal. From the discrete component circuit. Now we also implemented the discrete circuit for the demodulation of ASK. So this circuit is producing the modulation, and from this output we will take our original message signal by using the demodulation circuit of ASK signal. The circuit has been implemented as we discussed earlier. The output has been taken on the oscilloscope, and we can see that we are getting the desired output on our oscilloscope. So this was the modulation and demodulation of discrete components. Students should record these results and attach to manual to complete their manuals. That's it for this experiment.